Well, hi Geometry. Welcome to 7.1, Apply the Pythagorean Theorem. This is my first video of the year. I'm out of practice, so bear with me. Hopefully there's no glare, because remember I think I figured it out. If I do this at night with the overhead light off, it should work. So I can find the side lengths of a right triangle. I can apply Pythagorean Theorem in real life problems. Okay, so little bit of this is going to be review. It was interesting in class today. I talked about the special triangle 45, 45, 90, so we'll be approaching that. Probably not today, but in the near future. So here we go. So solve x squared equals 81. Well, a lot of people like to just take the square root, and when they take the square root of both sides, here, let me just do that in red so you see it. You've got to be really careful. You can't even see that red. I guess that would be the problem about not having the light on. Okay, any case, well, let me know if it gets blurry. So when we square this both sides, you're going to have x equals not just 9. Notice I purposely left a little space here. It's plus or minus 9. Okay, let me try black, because the blue doesn't seem to come in well. How about this one? Solve for x squared. I'm going to subtract 12 on both sides first. And when I subtract 12 on both sides, you'll have x squared is equal to 36. And then take the square root of both sides. It seems like it focuses in late or something, doesn't it? Take the square root of both sides, and you'll have x equals not just 6, but plus or minus 6. So if you've noticed so far, we've been dealing with square roots. And I think it's also important to write down your perfect squares. Do you remember what perfect squares are? One times 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, 49, 64, 81, hopefully I don't miss one, 100, 121, 144, 169, 196, 225, that's 15 squared. I like to label that one because after a while they start blending in. 256, 289, 324, 361, and 400. I don't expect you to memorize them, but if you go through it enough, you kind of get the idea. All right, so simplify square root of 80. Now, some people can think, oh, well, as a decimal, or usually if it's simplified, they want the exact value. So to find the exact value, well, what you do is find your perfect square that will go into 80 nicely. And the highest one is 16. Okay? So this is the same as the square root of 16 times 5. So the square root of 16 is 4, and then we leave square root of 5. If they want an approximate value, okay, this is an exact answer. If they want an approximate value, well, square root of 80 is right before 9. So it'll be about 8 point something. And I'm actually using my calculator. 8.944. All right. Find x. Okay, x is this value right here. Okay. Well, that's actually kind of easy. I think I wanted you to find the height. Oh, in any case, so because that this is an isosceles triangle, and I'm assuming that this is also a right angle. Well, it will. The altitude will drop down, and this side will be the same as this. If this whole length is 12, then we know x equals 6. But how about the height? Well, let's look at just the right side of this triangle. I know this is 6 and this is 10. We're going to call this h. Well, we have a right triangle, so you can use Pythagorean theorem. H squared plus 6 squared is equal to 10 squared. H squared plus 36 is equal to 100. I'm going to subtract 36 on both sides. H squared is equal to 64. H is equal to plus or minus 8. But since I'm actually dealing with the height can't have a negative height. You use positive 8. So usually when you're using Pythagorean theorem to solve some type of problem, it's going to be the positive value. Okay? All right, so here we go, Pythagorean theorem. And I know when these print out, this blue won't come out nicely. But these are really nice to know. I think I might have a really nice big giant chart. But if you Google Pythagorean triples, you can get a nice big chart that has a lot of them. Obviously, this small little chart won't work all of them out. But if you have 3, 4, 5, if you multiply each one by 2, you also have 6, 8, 10, which is the problem that we just solved right up here. So these are Pythagorean triples. And I would say these right here, obviously the small ones, and this one, are the most popular ones that you're going to see on that ACT when you take your junior year in high school. It's a long way away, but you'll see it. Okay, so we have a right triangle. The segments that form the right angle are called the legs. The segment opposite a right angle is called your hypotenuse. Now the formula for Pythagorean theorem is the sum of the squares of the legs is equal to the square of the hypotenuse. So here we go. In a right triangle, the square of the length of the hypotenuse, so that's c squared, is equal to the sum of the squares of the lengths of each leg. So a squared plus b squared. You should be able to read a formula and understand what they're saying. But basically, we just have it right here. A squared plus b squared equals c squared. Keep in mind, remember how I took the 3, 4, 5, I multiplied each one by 2, and I got 6, 8, 10. If you just take 3x, 4x, 5x, where x could be any number, you'll have a triple. Okay, and you could do that with any one of these. Find the length of the hypotenuse of the right triangle. Okay, good. We're still recording. So these are both my legs. 5 squared plus 15 squared is equal to h squared. So 25 plus 15 squared is 225. That's up here. Is equal to h squared. So I get 250. And I know your book may accept the decimal answer, but I want you to start practicing with the exact answer. So h is equal to the square root of 250. And that's the same as 25 times 10. Remember how I did that? I find the largest perfect square that will divide into 250. It'd be 25 right there. So the square root of 25 is 5, and then square root of 10. That's our h. So far, so good? Otherwise, if you wanted to estimate, 250 is right between 15 squared and 16 squared. So it's about 15 point something. Okay, so 15 point something. And that makes sense. Your hypotenuse should be the longest segment. Okay, obviously that's not drawn to scale. Next page. Ooh. Andrew made a ramp. Should have changed this and put Alex. In any case, Andrew made a ramp for his dog to get into his truck. The ramp is 6 feet long. All right, so let's draw a little truck here. Okay, excuse my drawing. Okay, and we need a ramp. All right, so the ramp is 6 feet long, and the bed of the truck is 3 feet above the ground, so this is a 3 here. We are going to make certain that this is a right angle. It's a little 3 above it. Wish I made that bigger. Approximately how far from the back of the truck does the ramp touch the ground? So we're looking for this. We're looking for our hypotenuse. So again, 6 squared plus 3 squared is equal to x squared. So 36 plus 9, x is equal to the square root of 45. Okay, now to find the exact answer, this is going to be the same as square root of 9 times 5, which is equal to 3 times the square root of 5. Of course, that doesn't mean much for the normal individual, so usually when you have a story problem, we're going to find out what is our approximate answer. Okay, what's our approximate answer? Square root of 45, if you look at our original page, 45 is between 6 squared and 7 squared, so it's going to be 6 point something. So now do you understand why I prefer the exact answer? Because you don't need a calculator to figure it out. We need a calculator to find out what that decimal value is. Okay. Area of the large square is equal to the area of 4 triangles plus the area of the smaller square. Okay? So look at this. This is a ABC triangle, and so is that. And I have 4 of them. All right? So far, so good? I should probably highlight this. Okay, now it's really blurry. Real blurry. I gotta zoom in. Okay, so I have 4 of those triangles. And each one of these little triangles is the area is equal to 1/2 the base times height. So AB. So same with this one. 1/2 AB. 1/2 AB. 1/2 AB. So far, so good? And this is a square, so the area is equal to side squared, so C squared. So if I add up all of those, I should have the area of the whole thing. Okay, so here we go. The large squared, this whole large square is, one length is A plus B. Here, let me just draw it like this. Large square. A plus B, and then this is also A plus B. So if I want the area of this whole thing, A plus B times A plus B, remember length times width? That's going to be this part right here. And then this is the 4 triangles right here. So 1/2 AB, so there's 4 of them. And then this is the small square. Do you agree with that? All right, so this we have to expand it. Got to be careful. It's not A squared plus B squared. Remember, if you take A plus B times A plus B, you have to FOIL that, distributive property. So first, you have A squared. Outer is AB. Oops. Inner is AB. And last is B squared. I have 2 of those. So you have A squared plus 2AB plus B squared. That's this right here. Now here, half of 4 is 2 of AB, and then I have a plus C squared. Well, what if I subtract 2AB on both sides? A squared plus B squared equals C squared. How cool is that? So it's proving the Pythagorean theorem. Method 1. Method 2, use cheese nips, or whatever those little cheese things are. So if you take cheese nips, 1, 2, 3, 4, 5 by 5, 4 by 4, 3 by 3, if this length is 5, I don't know if I write it in if you'll see it. Let me try. 5. Can you see that 5? 3, 4. So the length of this side of the triangle is 3, this is 4, and that's 5. The reason why this is a 3 by 3 squared, square it. 3 squared, there's 9 of these bad boys. 4 squared, there's 16. 5 squared, what's 9 plus 16? 25. So the area of this plus the area of this is equal to the area of that. So add the cheese nips of the 2 smaller squares and add the cheese nips of the larger square. What do you notice? You can rearrange all these to get that. All right? Example 3, moving along. Find the area of the isosceles triangle with the side lengths 20, 20, and 24. So I went ahead and wrote them in for you. And remember with isosceles, you know this information. So let's just draw half the triangle. This is 20, this is going to be 12. We need to find the height. Why do we need to find the height? Because area of a triangle is 1/2 base times height. So it's 1/2, your base is 24, and your height is, I don't know. So we got to find it. So here we go. Using Pythagorean theorem. 12 squared plus 8 squared is equal to 20 squared. And I've had students ask, can I switch these around? Yeah, because it's definitely commutative. So 144 plus 8 squared is equal to 400. So I'm going to subtract those. Subtract the 144 on both sides. So h is equal to the square root of 256. And what's nice is that is a perfect square. H is plus or minus 16, but since we're dealing with the distance, positive 16. Are we done with the problem? No, because I want the area. So area is equal to 1/2. Let me put a 16 in here. 24 times 16. Well, 1/2 of 24 times 16 is 192. Now you're going to leave it as 192? Oh no. Units squared. So that is what we're looking for. A lot of work involved in that, but it's not difficult. I know you can handle this. A lot of review here. Find the length of the hypotenuse for when the legs are 21 and 72. Okay, we are assuming that these are all right triangles, but that is there. So I have 21 squared plus 72 squared. Why are these numbers so high? Equals c squared. So 21 squared is 441. Naturally, I wrote the perfect squares only up to 20 squared. Plus 5184. So 5,184. Add them up. 5625. Take the square root of each one. You're going to get 75. And that's going to be units. All right. And a nice simple assignment. So, well, simple meaning you have to write a lot. So this is 3 to 33 odd. And there's a reason why I have the odds, so you can check answers. All right, have a nice evening, and welcome back. Hope you had a good break.